This is Math for Cooking. Today we're going to be using math to make German chocolate cookies. Here's our recipe, and it's full of fractions. 1/4 cup, 3/4 cup, 1/2 cup, 1/8 of a teaspoon, 2/3 cup. You can't even bake these cookies without using fractions. But what I'm really wondering about is this part right here, and I'll show you why. I'm wondering about this 3 ounces of dark or sweet baking chocolate chopped. You might think at first, but that's not a fraction, that's a whole number. But when I show you the package that I got the chocolate in, you'll see how we'll have to use fractions in several different ways. Here's my problem. The recipe here says that I need 3 ounces of dark or sweet baking chocolate. However, the box I bought comes in a 4-ounce size. How am I going to turn 4 ounces into 3 ounces? I know right away that I'm going to have to cut something, and when I cut the whole into parts, I'm going to be dealing with fractions. Remember, the recipe calls for 3 ounces of baking chocolate. But when I open the bar, this is what I see. I really have 4 ounces. Can you think of a way to divide this 4-ounce bar into pieces so that I can somehow pull out just the 3 ounces that I need? On a whiteboard or piece of paper, quickly sketch some ideas about how I might be able to divide this bar evenly and just find 3 ounces. I decided to start by breaking my 4-ounce bar into half-size pieces. That's always a good place when you're deciding to break into smaller fractions because I know how to work with half pretty easily. This is 1/2, and this is 1/2. But what does that mean in terms of ounces? If the whole bar altogether was 4 ounces, how big is this piece? And how big is this piece? Well, I know that half of 4 is 2, so this side must be 2 ounces, and that means the other side must be 2 ounces too. 2 plus 2 is 4, so I found the half. In looking at that half, you might notice a fraction that could be another name for it. What they've done with this baking chocolate is divided it into littler sections, so if I just needed smaller amounts of chocolate, I could easily break it and get smaller even pieces. So you can see they've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The whole bar has 16 little segments if you wanted to break it up smaller. So another name for this fraction, this 1/2, I can also name this 8. 1, 2, 3, 4, 5, 6, 7, 8 little segments out of 16. Why 16? Because the whole bar had 16 of those little sections. 1/2 and 8/16 are called equivalent fractions. It's the same amount of chocolate, but we've just given it a different fraction name depending on the size of the pieces that I'm looking at. But let's get back to our original problem. Remember, I was trying to find a way to get 4 ounces and break it into smaller pieces so that I could just pull out 3? Well, the halves are a good starting point. But can you think of a next step that I should do in order to find my 3 sections, even if I have a little left over? I've decided after I cut it in half to cut those pieces in half again, so that now instead of halves, I have fourths. This is 1/4. This is 1/4, this is 1/4, and this is 1/4. Does this match the picture that you sketched out earlier for finding ways to pull out 3 ounces? Now let's take a look at how I'm going to get those 3 ounces. Again, if this whole bar was 4 ounces, what do I need to use to get just 3? How much is this bar in terms of ounces? How many ounces is this little section? See if you can solve that on your drawing and pause this video until you have an idea. Okay, let's see what you've got. Remember, if this whole bar is worth 4 ounces, and each of these is a fourth, then what you should have is, this is 1 ounce, 1 ounce, 1 ounce. Each of the pieces here are exactly 1 ounce. It's easy once I've divided it into those pieces now to find just my 3 that I need for the cookies. This section on the paper is 3 ounces. It's the only part of the chocolate that I need for the cookies. I've only used 3 out of the 4 bigger pieces of chocolate, or 3/4 of the bar. You might notice though that I could come up with even a different fraction for the same amount of chocolate. If I go back and look at those smaller sections, let's count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've used 12 of those little sections, the smaller pieces that you could break the bar into. Altogether there are 12, 13, 14, 15, 16. I didn't use all 16. I used 12 out of the 16th to make those 3 ounces. So 3/4 and 12/16, it's the same amount of chocolate. These are called equivalent fractions. I've just named them differently depending on whether I was looking at these big sections here, and I see those 3, or if I was looking at these little sections, in which case I see 12. Depending on the parts I was describing, that gives me my fraction names. But 3/4 and 12/16 are equal. So I've taken out the 3 ounces I need for the cookies and I'm putting the rest in my cabinet. But I decided to make myself a little note because the next time I take out a partially open bar, I might be a little confused. So what could I put right there as a note to myself about what's left in the box? I know that I've used 3/4 of the bar. And if I draw a picture of that, divide it in half, divide those halves in half again. I've used 3/4. From the picture I can see right away what's left. Oh, I haven't used this piece. So that means I have 1/4 left in the box. And if this is 3 ounces, then I know that this little piece is just 1 ounce left over. So I'll make myself that note on the box and I'll be ready for the next time I cook. Thanks for tuning in to Math for Cooking. It's a good thing you're learning how to do fractions in several different ways, because if you didn't know how, you might not be able to end up with something like these. You've got to be able to make equivalent fractions in order to cook. Thanks for tuning in to Math for Cooking. See you next time.